All right, thank you all for joining our session here at SoloCon. We'll be talking about modern applications and how Google Anthos and Solo Glue Mesh come together to complement each other and provide a powerful platform for running these modern applications. So my name is Christian Posta. I'm the global field CTO here at Solo. I've been working on Kubernetes and Service Mesh for a really long time now. I've published a few books on these topics, and I'm working with a lot of our customers here at Solo to adopt these technologies successfully. And I'm joined here with my friend Richard.
Yeah, we've just been really Twitter friends for most of our time. So, I mean, we finally get to hang out in person. This is pretty awesome. Thanks for having me here. So yeah, I'm Richard. I'm a director of outbound product management here at Google Cloud, coming from a long number of years in application platforms and app development and fun stuff like that. I do a bunch of Pluralsight training on the side to supplement the meager Google income, and then also write some books. And I also screw around a lot on Twitter. So you'll see me doing demo threads and things like that, just because this is an awesome time to be doing app development, and I like to show off what we've built. All right, so yeah, I'm gonna jump in, Christian. I'll go through a few things kind of on the Anthos side, what's the point of all this kind of effort and hybrid multi-cloud stuff, whatever. Then I want to hear from you about kind of how Glue comes together with this. It kind of tells a pretty cool story together. You're going to show off some tech, which is always great. And then we'll send people off with their free puppy or whatever the conference gift is. So, I do like to start when we think about, all this platform tech. Like you and I, Christian, we geek out over tech, I think, and enjoy this stuff, but it's still all in service of outcomes, right? We want to build better software, do better business stuff. And when you look at the State of DevOps report and the last version we did last year, we're kicking up 2022 right now. But when you look at it, look, good teams at software do two things really well. They ship more often and they keep their systems online more, right? Everything we're doing should be somewhat in service of that when we're building platform tech. By helping you ship more often, reducing complexity, making life a little easier, but not sacrificing stability and resilience. And at the same time, this data is starting to show that this isn't nice to have resume-driven development stuff. This is like, you're probably better at your core business when you're doing these things. And you're probably having better employee retention, and you just like going to work a little more when all you do isn't wrangling your tech. And instead, you're just using that to unleash really awesome stuff. So whatever we're doing at those Kubernetes service meshes, none of it matters if you're not achieving these things. Although I think together we think that we do help this a lot. And so Forrester just came out with this data, which showed that in their recent public cloud container wave, but look, we're really working hard here at Google to have a premium container experience to enable some of those outcomes. We believe, containers are the modern unit of compute at this point. VM's too big, function sometimes too small. So when we think of a container, it's really an ideal unit of compute today. Google's made investments on this from the beginning. And so we work hard at saying, how can I help you ship a little faster and have some really stable runtimes? And that manifested itself by being the top rated hyperscaler in terms of just like a complete container platform end to end. So we're happy about that. So some of this, of course, look, if I were waving the magic wand, you wouldn't use anybody but Google Cloud because you make great choices. But that's not the world. I get it. You use other stuff. You're on premises in other clouds. And so kind of Google from the start's been really good about investing in a lot of open source tech and other platforms to make multi-cloud a little better. Is it great? I don't know. Can we make it better? Of course we can. So when I look at how we're investing at multi-cloud, and kind of first, are we investing in the open source frameworks, right? Front end stuff like Angular and Flutter, or even writing in Go, back end stuff like Istio and Kubernetes and Knative and TensorFlow and all kinds of great stuff. So I want those great outcomes. I'm probably using some containers. I'm also probably using open tech. That's a huge part of this investment. But then we also want to make sure you're getting those outcomes and you're getting that speed by good platform tech, not just like, here's open source, rock on, figure it out. We want to make sure we're giving you some of these stacks. And so nobody's doing what we're doing here. We're putting, you can use BigQuery on Amazon and Azure today. That's mind blowing. I can do GKE that way with Anthos. I can run Cloud Build doing it in a hybrid way. Cloud Deploy, I can connect hybrid workloads. I can do things with Apigee everywhere. So we're working hard to not just throw you some great open source stuff, but also can we make this into products and platforms? And then finally use some of the practices. Those numbers I showed you at the beginning, those DORA numbers, like that stuff you can do anywhere. It doesn't have to be in Google Cloud. We make it fun, but you can do that stuff anywhere. Same with SALSA, right? The Secure Software Supply Chain Standard. That stuff that, yeah, we're going to work really hard to make it awesome here. You can do that anywhere. Like that's awesome. So practices, platforms, underlying tech, I think kind of all those come into play on multi-cloud stuff. I guess I'll pause for just a second, Christian. When you think of the multi-cloud stuff, this can either be a complete dumpster fire or you can do this stuff intentionally and it's not too bad and maybe even accelerating business. Kind of in these areas, these are things that come to my head when I think of what you need, but any other things you think someone needs when they're trying to achieve those first outcomes and trying to solve that in a multi-cloud way?
I know these are absolutely great foundations. Practices is something that kind of gets overlooked. People get very excited about the technology, and there's a lot of great technology, and we'll talk about it today. But I guess I'll reinforce the cloud native practices are extremely important. Like you said, you can do them anywhere, but just make sure you do them and you do them right.
Right. Like I think I know, and I tell people, if you're trying to future proof, you're going to do three things. You're going to bet on containers, infrastructure, automation, and continuous delivery. Gosh, if you figure out those kind of practices in general, not to mention just good resilience engineering and stuff, I don't care what cloud you use, you're probably going to be in great shape. So
right.
Part of this for us manifests itself with this approach. If I look at how Google's trying to do stuff, we're doing open APIs all over the place, but proprietary kind of googly implementations, which is not shocking, right? I think the industry has said, arguably the API is more important than the implementation nowadays. Like you see, we just launched our Google Managed Service for Prometheus. Awesome. It's a drop-in replacement for Prometheus. It's amazing. But what makes it really amazing isn't necessarily that interface. It's the fact that it runs on Monarch, this underlying system at Google that we use ourselves that takes a ridiculous amount of logs in. Proprietary, just amazing system for us, but we put a Prometheus head on it. That's really powerful. And again, we'll support full Kubernetes. We just have none of the ops because we've automated the heck out of Kubernetes to make it really easy to use. So I love the fact that we're, as much as anybody, embracing open interfaces. So you have some portability, you can integrate with your best stuff. Glue is a perfect example. I don't want some weird proprietary stack that I can't bring best of breed technology into. What kind of stack is that? I want open API so I can integrate best of breed at my edge, at third parties, in the cloud. So that's kind of the bet we're making there. Now, GKE, as I mentioned, is a real, I think, premium representation of this, from security, scale, functionality, right? All these sort of things. It's unbelievable. I enjoy using it, and I don't love writing YAML, which should be enough of a testament that even I will enjoy it. Because look, we've automated the heck out of it. Nobody's offering a fully automated Kubernetes like we are with Autopilot. Literally, we do the scaling, provisioning, patching. We get paged. Our SREs get paged if something goes wrong. So made a huge investment in fully automated Kubernetes. That's great, right? It's an amazing foundational tech going back to those original goals. I want to ship more often and be more stable. I need rock solid platforms, and nobody's going to do Kubernetes like the company that built it. But of course, the hard part, and Christian, you and I have been in companies who helped build these stacks, but most people don't start at that base layer, right? Or they start there, but they don't end there. I got to add different layers. I'm adding application experiences, configuration subsystems, provisioning automation, service meshes, and that's all important. That's not bad stuff. That's amazing stuff that turns that into an app platform. Awesome. A lot of people can take that CNCF diagram and turn that into a stack, right? It's amazing what you can do now without having to buy a bunch of commercial software. You don't have to. But what I see is when people can do that in one place, cool. This gets really tough or tougher when I'm trying to maintain a consistent sort of fleet across different infrastructure, right? It just, is everything going to be compatible? Is the version of Istio you use here work with this version of Kubernetes? Does this compile with this? How are you getting logs from here? And so all of a sudden you end up with a 100+ person platform team because your custom platform, which was built to prevent lock-in, is now the ultimate lock-in because nobody has what you have. So it's an interesting world. We kind of use some of the open source stacks to build these kind of useful platforms, but they can be a beast. And so again, I guess I'll pause for a second because do you see that or am I making that up? Do you see that assembly
absolutely happen? Oh, absolutely. And it's not like organizations don't want to just go here, give me a platform that works. But they have a lot of unique constraints, assumptions, backward compatibility issues where they do need to kind of put these pieces together. And the question just becomes about how do you simplify it, right? That's what they're looking for.
That's right. And you and I have worked in places where it was often about turnkey platforms, and I love integrated opinionated stacks. I mean, I like that. I think that's great. For many, though, you hit that ceiling kind of quick about what other things can run there.
Right.
All of a sudden, I do want to swap in my choice for this or that. So I think the future is a little more around composability, purposeful integration, but composability. So, the nutshell for Anthos is saying, all right, we've had this amazing set of open source tech. We're trying to make this into more of a platform experience without necessarily bogging ourselves down with very heavyweight, kind of very complex platform, simplicity to your point, things like that. And so when we look at what Anthos is, look, it's a way to kind of have a distributed application platform that's backed by the cloud. I want to put this application platform and these application services on-prem, in other clouds, on Google Cloud. I want to kind of manage it from the cloud. So I'm not stuck with necessarily just like a software-driven stack in every place. I can back support this from the cloud. So kind of at the base, it starts with GKE. I can run GKE in Google Cloud, of course, but I can also now run GKE on a bare metal node at the edge. I can give me a box with 2 vCPUs and 4 gigs of RAM sitting at a retail edge, and I can run a full GKE cluster there. I can install that on Amazon. I can install it on Azure, or I can even attach your existing cluster sitting in EKS or AKS. It could be a Rancher cluster on-prem, doesn't matter. So it starts saying, all right, I got to start with the fundamental unit of compute, something that can run these containers. Terrific. Then I start thinking about, well, how do I manage some of that? So what Anthos can bring is some of the fleet management, because all these clusters are connected through the backplane to Google Cloud, kind of a thin connection. It can operate without it, but it kind of does that for basic operations. And so I can manage them, see them. We're making updates now to make it really easy to even provision and upgrade all through the cloud wherever they are. Then you get some application services, a cloud run experience for application developers, being able to deploy software, full integration with cloud ops. Maybe you say, I don't feel like dumping a bunch of logs into my on-prem stuff anymore. How about I just store that in our remarkably scalable log system? Cool, that just works. You don't have to worry about it. Full configuration management. So if I have 10 clusters, 10,000 clusters, how can I make them all look consistently the same? Same configurations, same policies applied, same security policies, really powerful stuff, and still with a common identity scheme. Again, if I'm running in Amazon or Google Cloud or in vSphere, doesn't matter. I can have a single way I do federated identity. So my developers go fast in all these environments. It doesn't matter where it runs, a single API for my devs. And I can have maybe a better ops story and a consistency story because I don't have a bunch of snowflake environments everywhere. I can have a consistent fleet, even though it might be distributed across environments. So that's what we're trying to solve, is take the best of open source to build a more composable stack that can run everywhere, but backed by the cloud.
Right. And so now that's where we jump in. You have this powerful foundation for running your applications, especially in a large scale. Mm-hmm. And where we come in is you've deployed the applications. Now these things need to communicate with each other. And this is where I spend most of my career, is in building large scale resilient distributed systems from a networking perspective. How do these things communicate and talk with each other? And when I came over to Solo and joined Adit here at Solo, our goal was to, how do we simplify how those connections are made and how developers influence the configuration, the behavior of those connections, and how they become secure, and how do we manage the policy around that from a more centralized place. So similar in some respects to what Anthos is doing, is what we're doing, but we're focusing on the networking layer, the application networking layer. We are investing in bringing together a lot of these powerful open source projects that do things like build the layer 7 proxy, like Envoy, or that bring the control plane, like Istio, or optimize the networking paths at a little bit lower layer, like eBPF. And then we are trying to expose additional application protocols and make it simpler to pull data out of these services that are eventually running with things like GraphQL. So I'm going to go a little bit, a level lower, and explain a little bit more about what it looks like to manage the application network on top of Anthos, or your wherever you've deployed your applications. And so once you get started, right, let's start off small, right? You don't usually start off by deploying 10,000 clusters. You'll start small. You'll maybe bring something like Istio in, and you start to expose some of this capability and some of this functionality out to your teams. And I've seen people do Helm and all of these various scripts, and maybe plug it into CI/CD, or give the developers free access to Istio virtual services and so on. What we're doing here at Solo is how do we make that easier? We know in enterprises there's lots of assumptions, and there's lots of weird ways that you would never have expected, at least as an open source developer, that people would be using your software. And what we try to do is abstract that, those enterprisey details, and give them first-class support for things like multi-tenancy, things like Istio lifecycle upgrades, and doing this without taking down your applications, because there's some thorny things that Istio does at times to get in the way there. So we've tried to automate away a lot of those best practices, the things we've learned in the community, things we've learned from our customers, and build this layer of abstraction to make it easier to interact with Istio and do that in a multi-org, highly tenant-driven environment. But we don't want to go all the way to what the traditional enterprise apps did, where they built these big clunky UIs and proprietary configuration formats and all this stuff. We want to stay true to the configuration as data approach, and building workflows into Git. So everything that we've built here at Solo, like our Glue Mesh management plane for managing Istio, everything's driven by declarative configuration and can be popped into a Git-based workflow or a policy engine like Anthos has. And you don't get tied down into those finicky, hard to use and hard to automate APIs. The next step we bring to the table is, how do you get traffic into these clusters, and how do you do that following a very cloud native and GitOps approach? So what we've done is we built an API gateway on top of Istio. And this is technology that we've had and been running now in production for the last 3.5 years, where we've extended Envoy. We've built filters for doing things like request transformation or data loss prevention or web application firewalling. And we've baked it into the proxy, and we've tied it into the Istio control plane. And we give you a API that you use to drive the policies about integrating with OIDC or LDAP or OPA, how traffic should be routed as it comes into the cluster. And we follow the same abstraction, the same API that we would use for the east-west traffic. So now we're not making a distinction that this is a totally different thing just for edge use cases. This is a traffic management system. We have a gateway as part of that. And we can use the same APIs for driving the behavior of so-called north-south directional traffic, as well as east-west directional traffic, including security and rate limiting and all of these things. Now, it gets more interesting once you expand out to more than one cluster. And a lot of our customers are running this way for high availability and failover, and even more tight controls over tenancy and so on. So we've built the developer portal that allows you to self-service and get access to your APIs and drive the policies about how things should be secured and how routing should happen, whether that's at the edge or in the east-west direction using the developer portal, and building self-service on top of a communications platform like this. Again, the dev portal is driven by custom resources. And there's no extra operational database, all these proprietary formats and UIs that you would see in older legacy tech. This is all completely, you can drive the developer portal, you can drive the traffic routing and security policies directly through your GitOps engine. But then getting to multi-cluster, this extends out, right? So now you can get a consistent multi-cluster API for managing your traffic policies and your access policies, extension policies. Maybe you want to deploy WebAssembly extensions into your data plane across multiple clusters, right? We focused on having a single pane of glass and a single point of entry for end users that simplify the operational and end user experience of managing these, because this can get kind of tricky, right? It's not just about placing the exact same configs on all the clusters. What we've seen in our users and our customers is that some apps are deployed on some clusters, other apps are deployed on other clusters, and then maybe in a public cloud or in a different cloud, you have a different set of apps. But those apps are communicating with each other. There's compliance and regulatory policies about how they are allowed to communicate with each other. When things fail over, they have to behave a certain way. And so how the configurations and the policies differ between clusters and environments, that has to be kept somewhere, right? We don't want that in human heads and making changes to YAML and all this stuff without independently of what's really supposed to be happening in the other clusters. So the management plane helps simplify and codify a lot of these policies that then get implemented on the various clusters where they belong. And again, this can be stretched out to maybe you're on-prem, maybe you're in Google Cloud, maybe for some reason you have to go to another cloud. This is a way to effectively enforce multi-tenancy, bring along consistent API gateway technology, drive the policies and behaviors consistently. You might even have different versions, like you said, Richard, of Kubernetes or Istio, and you need to kind of unify and manage these all together. And so that's a big part of as you scale, as you get to the hundreds, thousands, tens of thousands of clusters, this problem becomes extremely difficult. And are these the types of things that you're also seeing when people are deploying out to lots and lots of clusters, potentially on maybe multiple clouds or on-prem and so on?
Absolutely. Yeah, especially as you say, not all clusters are going to be identical with their workloads. Some are using Dev Test Prod. I was talking to a company this week that does dev on one cloud and production in Google Cloud. And they still have to promote consistency between those and some of the stack and traffic. And so that's coming up more and more as people start to take advantage of things in different places. So something like this is killer. That's super helpful.
Right. Yeah, exactly. And I want to stress, because it is something that I've seen over the course of my career, where people adopt new technology. They're so excited, vendor says it does a million different things, and then they put it in place and they realize they created a new silo, right? And all of the processes and stuff that they've created create more bottlenecks. So I want to emphasize again that this plugs into what we believe is the right way to build automation, to build self-service. We hear from our customers all the time that GitOps based and configurations data based workflows significantly improve the developer experience. So no matter how complicated, you might be using the edge gateways and Istio and eBPF and all this stuff, you don't have to worry about all that. Glumesh is managing and simplifying all of that stuff to improve your security posture and the power of your application networking. Now, this is a little bit busy diagram, but what I've tried to do is distill some of the architectural patterns that we've seen where people are deploying this application networking technology, service mesh, this kind of stuff across multiple clusters, potentially clouds, multiple clouds, or on premises and public cloud. And there's DMZs, there's virtual machines, there's all of these different maybe different lines of business and organization, all this stuff. But what we've seen is the power that you can get over the network like this when you push the policies down to the level of the application. And operationally, you can simplify this if you're using a lot of the same technologies, regardless of where you're deploying. And then, like I said, we come in, we support all that stuff, and we build the tooling to simplify the operational experience around it. So Glue Mesh Enterprise is the product that we sell and that we, deploy at our customers. It comes with Istio support, multi-tenancy APIs, extensibility with WebAssembly, a native API gateway built on Envoy proxy, and these end up being the foundations for a very powerful control over application networking. Like I said, developer experience is one of the biggest things that we see that our customers are very excited about once they've actually proven this out. Getting the consistency of operations is huge. It reduces manual mistakes and configuration errors and ultimately outages. Being able to set up multi-cluster for high availability, dynamic failover, so you don't have to go in there and say, all right, I want this percentage of traffic to go here and there. It's just, you can set up locality rules or priority rules, this type of stuff. Plug it in with your cloud CAs and your PKI to get a little bit more zero trust foundation in your communication. And then of course we support VMs and a hybrid, a diverse types of workloads. So enough talking, how about? And we jump right in and show you Anthos and Glue Mesh working together to provide some of these benefits.
Awesome. Let's go see it.
So let's take a look at our demo environment here. You can see here through the Anthos dashboard that we have 3 clusters deployed, 2 running in GKE, 1 running in Microsoft Azure. If we click on the workloads, we can see all of the workloads that are running across these clusters. You can see Istio is deployed, and some parts of the book info demo are also deployed, which we'll go into in more detail in a moment. We can see some of these endpoints are exposed publicly as gateways, and we'll also talk a little bit more about what those gateways do. From the Anthos dashboard, you can also see what configuration policies are set up for these clusters or groups of clusters. For example, if we take a look at the policies set up for one of these clusters, we can see that we have things set up where certain users and groups of users can deploy apps and configure the apps a certain way. In this case, we're limiting resource usage or restricting to setting up just certain IPs. And these policies get enforced on the cluster by a gatekeeper and provide a level of consistency across these clusters. We can even log into the clusters here that might be running in a different cloud. So for example, the Azure cluster. So if we come over here and get the credentials to be able to log in, we can kubectl get nodes, and we can see that we have access to the Kubernetes cluster, the Anthos cluster running in Azure. So once you have your platform set up and your cluster is running, you need to deploy applications, you need to control the traffic, the security policies on the wire between the services, and that's where the service mesh part comes in. So we saw Istio is deployed. Let's take a little bit closer look at what the platform or what the demo environment looks like. We have 3 different clusters. 2 of those clusters will be running data plane components, workloads, the service mesh itself. One of those clusters will be running the management plane, which is responsible for providing an API on top of the multi-cluster environment and for actually building, orchestrating, reconciling configuration across this environment so that it's consistent. And what I mean by consistent isn't that it's the same on every cluster, but that given the context, it is correct. Let's take a look at an example. So in cluster 1, we'll have the book info demo, and we have product page deployed in a namespace. We have the rest of it deployed in a separate namespace. But you can see we've overlaid an additional construct or API on top of this called the workspace. And so in Glue Mesh, a workspace allows you to group namespaces together for a specific team across multiple clusters. So in this case, we have the book info workspace. It has a couple namespaces in here, and the book info team then has the ability to go in and configure routing, security policy, this kind of stuff for their applications. We also have another workspace called the Gateways workspace. In this workspace, we have deployed the Glue Mesh Gateway, which is built on top of Istio's Ingress Gateway. This adds rate limiting, external auth capabilities for OIDC, this kind of stuff. Also has request transformation and web application firewalling built into the proxy itself. And so the gateway team can configure and expose, the ports and protocols on the gateway and delegate that to the other teams, the book info team, which then can import the gateway workspace and export resources like routing tables and so on to it. Let's take a closer look at what we have. So we have the Glue Mesh dashboard here, and we have our two workspaces, book info and gateways. If we click on book info, we can see we have a few resources that are involved here, some policies that have been set. If we click on see more details, we are exporting to the gateways workspace, so we can control the traffic routing to our application from the configuration that we set. That gets exposed on the gateway. We see that we actually have some routing rules here and some policies set up that will go into more detail. We can also see that we have the two clusters, and we see the flow of traffic between the various workloads in those clusters. Here's the book info example itself, pretty familiar. If we refresh, we see that we're only on cluster 1. We should only see black stars or no stars. Right. So now let's say we want to specify rate limiting across both of the clusters for anyone calling the product page or this book info service. So for us to do that, let's actually, let's see if we can call the service in such a way that would trigger rate limiting, but we don't see any rate limiting at the moment. All of our configuration in Glue Mesh is specified as declarative configuration. So you can take a look at the objects here. We have our rate limiting configuration that will key off of a specific set of headers. And in those headers, when we detect them, we'll only allow one request per minute for requests coming in like that. All right, so these are our rate limiting rules, and we want to apply this as a rate limiting policy, in this case, to any routes that have been labeled with rate limited. All right, so you can see we're going to use labels and selectors we'll define the policies and we'll apply them based on labels and selectors. So it's an extremely flexible and powerful system. So to do that, what we want to do is let's take a look at our route table. And we see we don't have any labels on the routing yet. All of this is in Git, so we could check this out. We could check this out. We could come here. Let's go actually demo, and we want to let's just go into it. Find our route table. And let's add a label to it. We'll call this rate limited is true. And let's commit it. Now, if we come back to our Git repo and refresh, we should see that we have our label here, and then we can deploy it using whatever mechanism we like that fosters a GitOps-based workflow. Argo CD is what we're using here in this example. So we're going to synchronize our new configurations, which it will be enforcing rate limiting. We'll give that a second. Looks all good. And now when we come back and call the product page and just grab the headers, we see a 200, and now we see that we've been rate limited. This is more than one per minute. Now, what if we took down the product page service in cluster 1? Now, cluster 1, remember, is where we see traffic coming in initially here. We see black stars and no stars. What we're going to do is using the GlueMesh config, we've already deployed it, but what we're doing is we're specifying a virtual destination with a failover policy. If we take a look at that failover policy, we can see that we're going to do failover based on locality. So if the product page service goes down, the service mesh will automatically fail those requests over to a different cluster. So let's take a look at that. Let's scale product page down to 0. And let's come back and let's refresh our service here. So refresh, we see we're still getting traffic. Although we've scaled things down, we're still getting traffic. And if I refresh enough time, we see we actually get the red stars because we failed over to cluster 2 or the second cluster, right? And so that's where we have reviews V1, V2, and V3. So you can see that GlueMesh layers on top and around Istio and any of the clusters on which Istio is deployed provides a more simplified API for specifying things like what is a virtual gateway, which may span multiple clusters and becomes a decentralized API gateway, a virtual destination, which can use locality or priority and failover between clusters, things like workspaces to group configurations and security boundaries for scaling out in an enterprise, and giving you a consistent feel regardless of whether the traffic is coming in at the north-south or the east-west direction. With GlueMesh and our Glue application networking platform, there is no distinction between those directions. So let's go back and wrap it up now.
That was awesome. So you got that all working, first of all, which is always great. But then, I think, again, we see the power of having clusters in different places that might be serving different roles. But again, your connectivity, you're sort of bridging that gap. Because even as you showed your architecture, sometimes each of those locations may be somewhat independent. Maybe the app doesn't actually span clouds, but you might have certain things that are homed in one place that you call back to securely or what have you. So it's cool to see you can do that fairly straightforward and with some pretty mature tech. So awesome job. A couple of next things, from our side. I mean, look, GKE is easy to use. It's part of our free tier, at least for the GKE fee. There's some fee for the compute, of course, but you can jump in here on Autopilot. Look, Autopilot's amazing because you only pay per pod. You don't pay for the cluster. So spin up an Autopilot cluster, only pay when you have pods deployed and consuming that. So give GKE a try. It's an awesome way to use Google Cloud. At the same time, you might start looking at how do I use something like Anthos to deploy on-prem to vSphere or bare metal. Maybe I don't have to keep separate stacks between my on-premises microservices application platform and my public cloud. I can kind of bring the cloud to me a little sooner. So maybe look at Anthos for that. It's pretty easy to do now. It's one Terraform apply command to give me a cluster in AWS or Azure, which is pretty awesome. And I know we've got Glue and Solo products in our Google Cloud Marketplace. So that is the awesome way to consume that. And of course, I hope I see more of you, maybe even in person, coming up at Google Cloud Next. And I don't know, we're probably going to sucker Christian out there. So you can hang out with both of us.
I'm looking forward to that. definitely come check out what we're doing with Service Mesh, with eBPF, GraphQL, these types of things. We at Solo are very big fans of Google Cloud and GKE. We use it all the time, and so do our customers. We do a lot in the open source. Go check out our open source projects. Glue, Edge, and Glue Mesh are both founded on open source projects. And also, no better place to hear about the successes of running Service Mesh at scale than from our customers. Definitely go check out our customers page. So I want to thank you all for joining our session. We put our contact information up here. Please reach out if you have questions afterward. Richard, this has been a pleasure, doing this session with you. Look forward to future sessions as well.
Appreciate everybody watching and learning about this stuff. This is an awesome space. There's some complexity here, so it's still like get in there and dig and learn, but stuff's easy to try out. A lot of free software downloads. So experiment, learn this stuff, see if it's a right fit for you.